Hey, this is Peter VK Fourier, and the following is a series of clips we stitched together from our latest Brisbane VHF Group Show and Tell Day 2024, held at the Redcliffe and Districts Radio Club Clubhouse. So I hope you enjoy.
All right, everybody, I'll call you all to attention. Good morning. Michael, good morning. Welcome, everybody. On behalf of the Brisbane VHF Group and our host today, the Redcliffe and District Radio Club, whose facilities we're using here today. Everybody's very welcome, and I'm glad to see so many displays have been brought out for us all to see. So the two clubs are quite closely associated. We share a lot of common members, and we're very grateful, as I said, for the facilities to come here and have a place to set up a display like this. So the principle of today is that people have brought along their favourite projects, things that they're working on for anything from VHF up into the high microwave and beyond. And there is some equipment here that goes way beyond microwaves today for you to see. The displays are all set out. What I'm going to do as we go around is to ask the presenters to tell us just a few words about themselves and how they got interested in microwave operating, and then describe the systems that they brought along. Just a couple of housekeeping things. There is bathroom facilities here for those who need it. We do have a lunchtime barbecue planned for everybody, and there's tea and coffee and drinks. It's donations of the Redcliffe Group are running the barbecue for us, so there is a very low cost for things to eat, and the price of the cans is on the fridge.
And the coffee and tea is free.
Tea and coffee is free, just that you can use that as you wish. I would ask everybody if they wouldn't mind just signing in, so we've got a record of who's come today. It'll be useful in the future. So through the course of the morning, if you could just pen your call sign in there. So where should we start? Michael, let's start with you. Mike, if you could tell us a little bit about yourself and tell us what you brought with you today.
Michael, can I get you to stand over here and sign to
Radio. Well, I've been licensed since I was about 18. I've been interested in EME for a long time, but something that always seemed impossible. But I'd acquired a satellite just some years ago and decided to put together a transmitter. Initially it was 200 milliwatts barefoot, but I decided after a while I wanted to go something a bit more substantial, so I spent the last several months putting together a Kuhn-based unit, 30 watt, 10 gigahertz transceiver. And I've been bashing away at it for a while now. It's pretty straightforward. If you look at the unit, there's just the transmitter running into the PA. The PA runs into a circulator, which then sends the signal, all going well, out to the coaxial switch and thence to the feed. If there's any problem with the match, if the coax shorts or opens and it gets reflected back, it'll go back into the circulator where it will be directed, hopefully, into the load, which should dissipate things, hopefully harmlessly. Other than that, the only other extra feature would be the low noise amplifier. Other than that, it's pretty straightforward. Star ground, and the entire thing is housed in an electrical equipment cabinet meant to live outside, because this will be attached to a dish. I have a 1.2 meter dish at home with an alt-azimuth motor attached to it for moonbounds. And that's pretty much the story.
Tell us about yourself.
Yeah, right. Hi, I'm Cole, VK4UV, and this is my 23 centimetre EME array. W2HRO collapsible dish with one of his circular patch feeds. Then we've got our hybrid combiner and a Kuhn 23 centimetre LNA, which usually has bits of coax going back through, poking back, and then round the back here you'll see the ASL controller, which is all operated via PST rotator, and tracks elevation. Yep.
Who's the motor?
This one here comes from RF Ham Design, and it just counts pulses, just the pulse ring inside.
Okay, we don't have to control it here. That's
the controller's in a box outside. I didn't feel it necessary. Yeah, and it just uses WSJTX and PST rotator, and it just tracks and away it goes. It's half a degree resolution.
You had contact on it?
Yeah, I have. Yeah, so it's it's pretty simple and basic, really. It's about
Fold up?
Hey?
Does it fold up?
Yeah, it weighs about 4 kilos when it's all folded up. I just put the feed off. That all comes off, so it can be transported.
Let's have a look at that patch. That's beautiful, isn't it? It's so simple.
Yeah. So I've just got another cap, goes on, goes in the box and gets put away. So it's all just 3D printed. Paul Andrews done, him and his son do all that at home. He's got 2.3 gig feeds made for these things now, and he's done a wire mesh conversion because, as you can imagine, this is a bit like a parachute to breeze. But anyway, here's what it is. Thank you.
One smile for the camera, please.
Morning everyone, my name's Roy, my call sign is VK4ZQ, and I was first licensed in 1957. It's interesting that this is a VHF, UHF microwave group, but when I started, nobody went above 6 metres. 50 megs was it. So I've chased the frequency up to and including 10 gigs. I haven't gone any higher. Each one of these units here are transverters running off low power. The driving force is a 705. Each one of the transverters uses Kuhn modules, but it's designed so that they're all in the same box. They all marry up easily to the driving source. Any that have a box underneath have an amplifier built in. The amplifier again is built so that you can feed from the top into the bottom and make the thing a compact design. I have run much bigger dishes than I'm showing you here. The 10 gig 2.1 is low power, runs 1 watt. This one here runs 5 watts, but on those dishes, obviously the path loss is quite high. The dishes can be taken off and 600ml dishes put in their place. This grid pack here is 2.4. There is a pair of transverters down there. The horns for them are over there. They run off 600ml offsets. At the moment, everything can run off battery power. So none of this requires 240 volts, and each one of the units is designed so that we can monitor the current drawn, the voltage that's available, and you know exactly where you're going with the transverters. Each transverter has metering, so it shows drive, it shows applied volts, it shows output power. So it means that as you use the transverters, they look after themselves. They are switched with an IF switcher. The whole idea of an IF switcher is that the feed comes up, multiple control voltages, control relays, and each one of the BNC connectors goes to the transverter. So what you see on this table can be run by a 705. I think that's enough. Thank you.
I might be the second oldest licensee here, I don't know, but I was first licensed in 1960 in ZL, still going to school, and I was such a rookie that I, after doing the written tests and then fronting up to the RI for the CW test, I didn't know that you had to know numbers as well as letters. So anyway, he took me through it and I failed that, but anyway I eventually got it. These days my primary interest is weak signal line of sight work. I'm not interested in waiting for sunspot cycles and diurnal variations. Currently my main interest is deep space reception of various spacecraft. None of this, I'll get onto this in a minute. I just recently increased my own personal best to 615 million K from a spacecraft called Juno, which orbits Jupiter. Light time 34 minutes, and I was able to receive it on a 3.7 metre dish at 10 dB over the noise. So I've got a pretty simple setup for that. For terrestrial use, it's mainly microwave. This is a 5.7 gig PA, transverter, heatsink, etc. In fact, it's so new, I've only had one contact with it, with Kevin. Attempts with Graham at Vista Point were unsuccessful because of my antenna system. So this is interesting technology. This here is the PA, which is much smaller than the transverter. Does 60 watts at 50% efficiency with gallium nitride technology. So I do believe this is what everyone will be using. The 3.4, which is probably my favourite band. This is actually I wrote on here when I built this, September 2023. So it's a bit over a year old. Again, a Kuhn transverter. The purple, a lot of people will recognise that as a stealth amplifier, which is used to drive this Kuhn PA here. This puts out 150 watts and is quite a nice device. So these days it's microwave, both terrestrially, and the other interest that I have is EME. I've used that for with my 3.7 metre dish for EME, and it works fairly well. So I'm interested to see, there's far more equipment here, especially for the higher frequencies than this. So a lot of work has gone into this sort of stuff. Okay, well that's about all I've got to offer.
Equipment first of all.
Yeah, good morning, my name's Rod, BG4ARP. I can't compete with these other guys in terms of when I was licensed. I got licensed in 1978. I got out of AR in 1991 and late last year decided after a 32-year absence to get back into it and got set up on 270 and 1296 and then thought I'd like to have a crack at microwaves. So I thought I'd go for 10 gigs. So decided to go down East microwave transverter. They're out of Florida in the USA. 3 watts, less than 1.2 dB noise figure. The dish was a retired couple caravanning around Australia and they bought a large dish for remote areas. They had no further use for it. I found it on Facebook Marketplace. I got it powder coated. It's very compact. Everything just folds up. You don't have to actually detach anything and put it away. And it runs the IF is 2 metres, the trusty FT817, satellite GPS locked 10 meg oscillator, and around the back here we have a interface box that I built so you can just plug everything in. When you take it apart, you just unplug all your cables, fold it up, so you don't actually have to physically remove items. It's just a matter of unplugging cables and you're in business. So the best distance so far is 247 kilometres from Mount Cannigan near Gympie to Kevin down on Cameron Lookout. But who knows, we've got to try a bit further. I want to go over 300 if we can. So that's my adventure getting back into AR. I've been back about a year now, and this has been up and running for about, I don't know, probably about 5 months. That's it.
So I'm Kevin, VK4UH. I was licensed in 1971. So I had a go at most things over the years, and rekindled my interest in microwaves in recent years, and on the higher frequencies and the challenge that that brings. But I have had a crack at most things over that 50 odd years, including that. When I started, to get on 6 meters, you usually use the transverter as well. That was how you got up to 6 meters, and that's a philosophy that's carried on, where you use your main station HF radio or VHF radios now, and you use all the facilities in those and just transfer them up to a higher band on receive and transmit. So all of the facilities you've got in your radio, like all the speech processing and the memories and the noise reduction and repeater shift and the multiple modes and digital now, can all be done. So whatever you've got in your main radio, you just transfer up to a higher band. So I bought a couple of transverters along that I've assembled. On the far right hand side is the simplest of the three. I made that about 8 or 10 years ago. This is a 1296 23 centimeter transverter with a homemade PA that goes with it. This was the first time I played with the SG Labs transverters. This was an alternative to Kuhn Engineering. It's very, very cheap, made in Bulgaria, hence the name. And he now makes them for 23, 2.4, 3.4, and hopefully soon 5.7 gigs will come into his range of equipment. They are about the simplest way of getting onto many microwave bands if you don't want to build a gear yourselves. They're modestly priced. They come in for about 200 euros or so, and it's all in the box, basically. All the antenna changeover relays, the local oscillator, everything is in there, and all you do is plug a 12-volt supply, an antenna, and your driver radio, whatever that is. So the far right-hand one is, I think it makes about 35 watts, I'm sorry, on 23 SEMS. The PA I made myself with just one of those modules that came from mini kits in Adelaide. These are a bit different. In recent years I've put a lot of effort into making some quite high-powered transmitters. And high power not just to make the signals louder and win the contest. This is really about unmasking modes of propagation that we didn't know were there before. As you take the power levels up, other things start to appear, like aircraft scatter, rain scatter, auroral now, and even ionospheric scatter. So signals will get through even though there's no direct path. Often over the top of mountains, and it's quite possible to work hundreds and hundreds of kilometres with different modes. The extreme, of course, is EME, and these are probably both capable of running EME. So that means that any two places on the surface of the globe that can see the moon at the same time can communicate, and that's just about everywhere at some point. This one here, this is a 9 centimetre, which is the 3.4 gig band. This one actually holds the Australian record at the moment. We worked in New Zealand with this one on Tropo. This makes 100 watts of power. It uses a Kuhn transverter, which you've heard of. They come out of Germany, and a PA that comes from them. Stealth amplifiers we've seen earlier on, the purple brick. That's used as the driver for the main PA. So it makes a lot of power, but it makes huge signals at the other end as well, and it pushes back the boundaries of what's possible, both in distance and difficult terrain to get over. And so it's opening up whole new horizons for us now with a little bit more power. The one in the middle, this is 6 centimetres. That's the 5.7 gig band. This one only finished last year. This also makes over 100 watts. And it's based on Kuhn modules as well, including the Kuhn PA. A lot of work goes into keeping those panels cool, of course, so there's multiple fans in this one and large heat sinks to blow the heat away, and good quality preamps as well, so they're both plenty of teeth and plenty of mouth and good ears as well as the crocodiles go. So that's just a couple of transverters. I suppose this is the far end of the spectrum. This is the top end, about working distance, and that one down the bottom there, that's the entry level one. So that's for 23 centimetres. If you don't have that band in your own radio, this is the way to go for. So for quite a modest amount of work and price, you can get onto that band. Okay, thank you.
As a swirler in 1956, so I still can't catch it, all these guys. But when I actually started ham radio, I was an F call, moved myself up to a standard call, found two guys that looked after me really well, which was VK4NE and CRO, and we finished up doing, in the 2000s, 2010 or something, maybe earlier, a lot of aircraft enhancement going to and from Brisbane to Sydney and wherever we could. So my interest was always there, never in HF. So then about 2010 or something, I got involved with this group, and Doug and others have helped me through all what I've got. I've got a companion called AMG, and he really assists me all the way that I've got so far. So this is not mine, that belongs to Graham. This is a 1296 transverter. Unfortunately, that isn't there. It is a W1 G8Z multiplier. Forgive me if I'm wrong. Mini kits transverter, mini kits sequencer, and a little tiny 20 watt amplifier. So that probably come in around about $300 to $400. This one here is our latest. It's a 5.7 gig amplifier. It was bought from eBay at around about $200 round figures. It's been worked here. All this information here is on AMG's website and my club, original club, BK4WIE, or Brisbane City Radio Society, and that is now still under test. So that puts out 25 watts. We're always buying small 2.4 and so forth gigahertz amplifiers and blowing them up. Didn't understand why, and we found out that most of it had to be attenuated with, I learned about attenuators, and away we went. This one here is a 3.4, much the same as Kevin's. This is 20 watts. The amp comes from Europe. Bert, help me. Yeah, him. I bought that off him, and it's a SG Lab 3.4 gig transverter. I am not licensed to operate that, but I can operate it on field day, which it gets used for. So it's powered by a low-priced 24 volt power supply. In here is this particular figure here. It's got TCXO to try and keep it on frequency, and the whole thing is push to talk. We're trying to make it a RF sensing system, because this was built for the 705. These are getting built for the 905, and it doesn't have any, like most things that Icon build, only has one push to talk out, so you have to play with them. So anyway, that was that. These two things, that's something I picked up in Bundaberg, which is a Commander or KR400 controller, and we thought they were being converted to 12 volts. So what we did was we actually converted them to 12 volts and used the guts of the Commander or KR400 system so that we could run 12 volts on a field day, because that's everybody needs 12 volts. And the biggest down was the controllers are all 240 volt, hence the generator, blah blah blah. And this little thing here is something that was knotted out. It's just a small thing you buy at Bunnings, I think it's about 20 bucks, and it usually converts everything to USB. But in this case, this has been Peter EA offered us this particular type of down converter, or up converter, down converter, for a lot of projects we did in past amplifiers. But this then just gives us 12 volts. So we've got a small thing. This system, the 905 and this, and a camera are up in Bundaberg, and the fellow that sells the 905, I can't think of his name, he's a Japanese dude, was totally blown away with the fact that we could run it, the whole system off 4 amps, I think it is, 4 or 5 amps. So anyway, that's me. Thank you.
So back to me. Moving up in frequency a little bit, I brought along to see my 10 gig system. This has done thousands of kilometres with us now to all around the country, and been involved in tests up as far as Rockhampton, and actually it's been out in every field day or so for the last 4 or 5 years. Now, for me personally, one of the most interesting parts of doing microwave is the chance to use very, very high gain antennas. So you can make a little go an awful long way. The price that you pay for very, very directional antennas is that you have to be able to point them in the right direction, because otherwise all of their benefit is gone. And so part of this project has been the mechanism to actually be able to point accurately and repeatedly to within a couple of degrees of where you think your recipient signal is. So this one is set up on all based on using a surveyor's tripod. The chain at the bottom, incidentally, is so that it stops the legs splaying out, and when you're up on a windy hillside it's very easy for all your gear to get blown over, and just about everybody has lost a dish at some stage for being blown over and wrecked. So I actually use a ratchet strapped to an earth spike underneath this and squash the things down into its chain to stop it moving. But the aiming frame here is based on a rotary mill table, so rotary movement on the handle here can give you accuracy to, you can repeatedly get to within about a half a degree or so of and back to the same place. For elevation, it uses just a piece of threaded bar from Bunnings, and a few little bits and pieces that I got Bob 4AV to mill up for me on his systems, and some just some pillow bearings to be able to actively tip the dish up and down. I must be honest, this is almost a complete steal from Rex VK7MO. It's purely plagiarized from his work, I must be honest. But if it works, why bother to reinvent the wheel? So he was quite happy for me to build my version of it. He uses his for EME work on 10 gigs, worked all around the world. This system is probably capable of that. The transverter itself comes off. This is a Coon-based system, but it's all in waveguide, so there's no coax involved anywhere in here. So the transmitter and the PA generate the RF in microwave. The preamp on receive comes out in microwave. Instead of a coax relay, it has a microwave switch, which is a very complicated piece of mechanical engineering to physically switch waveguide from one port to another. In fact, the most difficult part of this project was getting that to work, because it has to be sequenced electronically. The transverter itself, this is quite high powered for 10 gigs. It makes 60 watts of RF. And with a 30mm dish with 33 dB of gain, that's a phenomenal amount of ERP. It's still only 60 watts, but there's a lot of ERP. And this system should be capable of EME. It's never had successfully been used for that yet. It's cut its teeth and works extremely well on terrestrial work too. We've had contacts with aircraft scatter, we've had contacts with rain scatter, and frequently work over mountain tops by knife edge refraction. With that amount of power, as I say, it does expose different modes of propagation that you wouldn't think about quite successfully. It's quite happy to run key down, so it's done a lot of its time running digital. Q65 is the mode that most people are using on 10 gigs at the moment, and that's what the EME guys use. the combination of high power and digital modulation has really opened the frontiers out for us and opened up all sorts of new opportunities. So that's a 10 gig system. Have a look inside. The mechanics are often as interesting as anything else. So have a look, see what you think. Well, it runs on 12 volts this one, but it does draw about 35 amps at 12 volts to get it to run. But it's basically a 12 volt system. And while I have the mic, I'll just show you another little one. Moving up again in frequency, this is a 24 gig transverter system. It's all built in, again, it's all based in waveguide, very small waveguide, but in waveguide nonetheless. Based on a Kuhn transverter and an outboard PA. And although this is still only a 600mm dish at 24 gigs, that has a phenomenal amount of gain, far more than at 10 gigs. And to point this one, again a bit of technology that's old stuff that's been reused. This is a gas lift. It was intended for a television camera. They were bought by the ABC in 1956 for the Olympics, and there's still a number of them around. So you can tilt the dish very accurately and very smoothly in azimuth and elevation, just by repurposing a bit of old technology. So it makes 2 watts, which is quite a substantial amount of power. We've done 300 kilometers on 24 gigs, which is not a bad effort by anybody's standards, but there's a lot more to do. Thank you.
Hi there, I'm Doug, VK4OE, first licensed in 1967, and still playing around with bands 2 meters and above. They've asked me to talk about this little 47 gigahertz system here. It'd be good to be able to take the lid off, but anyway, that's a sort of a horn that looks ever so tiny, but it's really quite high gain at 47 gigahertz. But this works with an ICOM FT817, and it's configured inside such that this one go from 10, I can't remember. There's a whole lot of stuff outside that you can have a look at, of things that I've built over the years, from 10 gigs, 24 gigs, 47 gigs, 122 gigs. So this is just one of the other incidentals along the way. This was the second system, but the trick is it's got one of these waveguide switches that Kevin was just talking about. And from the transverter it can be sent, the signal can go straight through on transmit and back on receive. If you want, you can have power amplification on transmit. 50 milliwatts will come out of it there, but on when it's in this mode here, it's only about 100 microwatts. So that's there. This switch position is what it calls safe. Nothing's connected to anything. And this switch position here is where the signal comes in here and is amplified on the way into the transverter. There's discrete components, waveguide components that are used inside there, and they're sort of unobtainable these days, many of these things. That's probably all I can say about this thing, short of taking the lid off, which would take half an hour.
Here's Rod again, who's already spoken. We're going to go to the extreme range of frequencies now, and I'm going to ask Rod to talk about his optical systems.
Yeah, thanks Kevin. Yeah, for those that have forgotten me perhaps, I was on recently, VK4OE Rod. Several months ago we had a BVHGF Group meeting, and we had a joint presentation from REAST, R-E-A-S-T, which is the Radio and Electronics Association of Southern Tasmania, and there was a presentation by Rex, VK7MO. Rex used to be the head of the CSIRO Antarctic Division, and in his own words he's got his OBE over bloody 80. So he's very heavily into what Kevin described, and he's also now very heavily into transmitting with light. His presentation was very good, and it prompted me to cobble together some optical transceivers. I mean, how hard could it be? So this was the result using a couple of torches, and just to prove that they work. You can't get good torches nowadays. Stop it. Okay.
Echo 4 testing, 1, 2, 3.
4, 5, 1, 2, 3.
3, 4, 5, 1, 2, 3.
4, 5, 1, 2,
3, 4, 5.
So they're a big hit with the kids, the grandkids. I love them. I've had these out to about 100 metres now in range, and I'm pretty sure they'll go further if I could bother to walk that far. But it's prompted me to have a crack at some higher power stuff, and I believe Kevin and Cole are making noises about getting on that too. The guys in Tasmania have bridged Bass Strait already with light, so from VK7 to VK3, just with a light transmitter. I'm not aiming to do that, but I would like to get over 150 k's if I can. Rex told us stories about how they go out onto mountaintops with these absolutely brilliant red LEDs, and there was an occasion where a guy was transmitting on a place called Mount Horror, and it was bushfire season, and the fire towers were manned at night time, and they saw this massive great red glow and went, bushfire! And of course when he stopped transmitting, the bushfire went away. So it took them a while to find him, and when they found him, they were quite relieved it wasn't a bushfire, but that led to concerns about, public concerns about all this massive amount of red light in the sky. So what we're proposing to use is a far red or very near infrared LED, 740 nanometres, which is still visible, but nowhere near the staggering bright red lights as you can see in that picture. The LED is 10 watts. It's not really that hard to put it together, but as with all things optical, everything's got to be aligned. If you're trying to focus someone from 150k away onto a little tiny receiver, photodiode, then everything has to be pretty well aligned. So that's one of the things I've got to get to grips with, is building the containers, the boxes for this. I'm gradually getting all of this together, and it's not that expensive. The receiver is a Texas Instruments OPT 101. They make it with a photodiode and a transimpedance amplifier all built in ready for you, which avoids all the problems of home constructed transimpedance amplifiers with stray capacitance and all sorts of things happening there. So hopefully I'll have this running by maybe the end of January. And that's it.
Just a quick question.
Yes.
Is the red, when you said red, is the red the preferred colour for this?
Red of the 660 nanometer red LEDs were chosen because red is attenuated less in the atmosphere than other colours. And it's the 740 nanometer LED that I'm using is attenuated even less than that, and puts out more flux than the LEDs that they were using to red. So red is the preferred colour, but when you get up into the power that they're running, and they've got massive great beams of red light going in the sky, it does cause people to wonder what the hell's going on. So,
What's the frequency, Rod?
the frequency?
Yeah.
Terahertz.
The still radio. I'm going to be side because the light behind you is terrible. There you go.
Talk about his gear. Hi, I'm Gary, BVHGF. I've had a licence since 1973, not 53. Recently come back to amateur radio in about 2015. I dabbled in microwave stuff. I built the VK3CV equipment, that's the test oscillator. And this is the current rig I use in the field. These are the only, and 76 gigs. They're the only really portable equipment I have. The rest is at home. I use a reflector at home on my tower. And I can cover anything from, HF right up to 76 gigs on the tower. getting back to the 122 gigs, Stefan VK4 CSD and I did a world record, surprisingly, on 122 gigs of 52 kilometres at one stage, and we didn't bother about putting the claim in, but there you go. So I've dabbled in Deep Space Network, like Trevor, and I managed to hear a bird flying around Mars at 60 million kilometres, which is only a minor thing compared to Trevor, which is truly amazing. Anyhow, yeah, that's about all I've got, guys. Thank you very much.
Introduce Graham too, if that's all right. Okay. So I particularly want to introduce Graham and thank him very much. Graham, VK2QJ, you've got to get the right call area in there. Graham has brought his display all the way from New South Wales to demonstrate to us today, and at that point I'm going to stop and let him tell you about his creation. Thanks, Graham.
No worries, thank you, Graham, VK2QJ. Nowhere near as licensed as a lot of these guys. I'm only a newbie in 85. Only recently in the microwave, probably 5 years in the microwave, 23 centimetres many years before that. And this is an ever-evolving caravan come rotatable tower in about its 5th generation. And starting up, I'll lower it down a bit later and show you it in its tilt up, tilt down, but starting from the bottom up, we've got 5.7 gigs with a 905 driving that, with a 10 watt PA at this stage, and a 15 dB receive preamp, soon to become a 50 watt PA. Up a little bit higher, you can see the PA in behind the 2 grid packs. That's 3.4 gig 100 watt PA, and a 20 dB receive preamp into the 2-phase grid packs, giving 30 dB gain with a bit of losses in that. Approximately 80,000 watts EIRP coming out of that one. Successfully chatted with Trevor 10 times through the last field day, plus 25 over 9 dB both direction every time. Rock solid contacts. Going up above that, we've got 2-phase grid packs on 2.4 with a 20 dB masthead preamp and a 100 watt PA inside the shack that will soon end up mast mounted to get rid of any losses. And then finally a pair of 35 element 23 centimetre Yagis with a 20 dB masthead preamp and 180 watt PA inside. The entire tower, shame I can't rotate it, the little inverter's playing up, so manually I can probably rotate it for you, but the entire tower rotates, so let a little bit of weight off for you, and hopefully I can manually rotate it, but the whole thing's designed to rotate wherever you want to, full 360 degree normally with the rotator, but as I say, the poor little inverter's having trouble. It's only a 150 watt inverter at the moment, so I normally run a generator with that one. The whole tower is designed to lay down.
This is an impressive job.
Hi, Doug, back with you again. I've just set up a selection of tripod units on my van here. I've a simple version of what you just saw from VK2, but that's on the top there. But I'm not setting that up today. Everything here is just on tripods. So the lowest band amongst these ones is the one that Peter's leaning on, and it's not complete, but it works with it. Just loosen it here. FT817 joins on there, and it's a small. The antenna is included. The big patch antenna on 10 gigahertz, and all the electronics generates a watt of power on transmit and a good sensitivity on receive. The next band up is this one here, which is not completely wired up. It's just an example sitting on the tripod. It's generating a watt on 24 gigs with a low noise amplifier, and that's all steerable quite easily once you set up the horizontal plane. It stays in the horizontal plane, and it's quite good. I've had many contacts on 24 gigs with that one. The next one, apart from these things that are for sale, this one here is on 47 gigahertz. It's actually live and up and running right now. There's an FT817 on top here, and a transverter box here which comes out on 144 megahertz with the FT817, but it takes its 47 gigahertz signal input and output with a waveguide connection underneath here. And then that waveguide connection goes down to the things that happen at near the focus of the dish, which is there, the dish being a machined dish, and these two modules here provide a low noise amplifier pass on receive, and look and see what's is it. So is that nothing, isn't it? Yeah, that's pretty hot, because that shouldn't have been in transmit all the time. Anyway, that's in receive. So the routing here is coming from the antenna. It goes out through one of these amplifiers around the back here and back into the waveguide switch, and on its way back up to here. And when it's in the transmit mode, it does the other thing. The transmit signal comes up here through the waveguide switch around the same pathway as before, and generates nearly a watt on 47 gigahertz right at the focus of the dish. So I like using this. It works very well. And there aren't too many other stations around at the moment on 47. We'll put that in that pass-through mode. So that's 47 gigahertz. I do have 76 gigahertz equipment, but I didn't bring it along today. But here, if I had an FT817, I could put it on here. And this one's on a very tiny waveguide. You just look and see that feed point there, compared to my fingernail, your fingernail or my fingernail. That's on 122 gigahertz. And it's a VK3 CV design. And but this has been put together with one of these, a type of dish that we know is working very well at above KU band where it was designed. And but this has got facilities for hinging it there and adjusting the tilt. The tilt of the whole antenna can be adjusted that way, and the rotating, the azimuth plane here can be fixed and set in one position. That's enough.
Okay.
Yeah, that's recording now. Hi, I'm Peter VK4EA, currently involved with the Brisbane VHF Group, and I've been licensed since about year 2000 when the Morse code was dropped, and before that he wasn't really bothered getting a HF licence and went to the CW. And as soon as I got the limited licence and got access to HF, I got bored of HF and went straight to microwave, so there you go. All I've got on display today is the VK4 RTT beacon in construction right now. So this is based on two RS0s, so one's on 144.440, the other one's on 50.285 megahertz, and we're currently experimenting with the modulation mode. So at the moment it's set up for CW, FSK, CW, and River Carrier and PI4, which is a very popular beacon modulation code in Europe. Just recently, Bo from RS0 released a couple of new sketches which will allow Q65, JT4 and JT9, so we're going to have a debate in the club about what modulation we're going to use on these beacons, but that's currently banging away barefoot at the moment, and I can on the 705 you can hear the tone at the moment coming out of the 2 metre beacon, and we go straight into the PI4 now. The other cool thing I'm doing with this is we're going to have some remote control. So through the Raspberry Pi, which is here, which is currently powering the RS0s as well as getting the serial status, these relays will control the PTT and bias controls on the PAs, which are going to be in a separate box, and I've got some nice multi-pole connectors to use to interface all the other measurements as well. So we're going to be getting in the forward power, reflected power, voltage and current into a live dashboard. And I was inspired by the recent lecture, actually a few weeks ago, a couple of months ago now, and the guy was talking about node red, using that in amateur sphere, and I reverbed everything in here on this Raspberry Pi with node red, and that's simply an amazingly quick way of getting a dashboard up, or a web dashboard for things that are valuable for certain users, so you can remotely manage the beacon, shut it down, turn it off, see any faults, get notified by faults almost immediately by web browser or by WhatsApp message. So that's that project in place. So that's work in progress and getting there. And that was decoding the PI4, but Colin VK4UH have been mucking around with it. Damn you, Colin. So what we're trying to do here is we're not so successful with the 905. So this is my 905 setup. I've got a very, very, very quick setup on a tripod. I'm only running 2.4 and 5.7 today with a camera transmitting ATV FM on 2415, and we're going to just go into the next building. It seems to be transmitting quite fine, but the lit TV is not loading the video properly. And that's me. Just tap that. Okay, ready?
So, getting on microwaves until relatively recently has always involved a bit of constructional work. There was no system that you could buy which was open the box and get on the air, but that's no longer true. Back last year, ICOM released the first, what they call an SHF, super high frequency transceiver, which is the ICOM 905, a transceiver that was multi-mode and covered all the bands from 2 meters, 70 centimeters, 23 centimeters, 2.4 gigs, 5.7 and 10. And also has an outboard module for 24 gigs coming. It's multi-mode, so it'll do everything with digital audio, FM, SSB, CW, and also ATV. So that's what we've set up today. You saw Peter 4EA's transmitter outside. That's just sending on FM video on 2.4 gigs, and we're receiving it here. We'll talk about this dish system in a moment. And there's a perfectly P5 copy picture on the little screen on the radio. This also has audio interleaved with the video, so the same as your standard television pictures at home. So that's there. So when you use this, and it's transceive, so with your camera at either end, you can just have a proper QSO with vision and audio at the same time. So this is being done on 2.4 gigs. We did hope to get the audio or the videos flown up onto the TV screen on the wall. Unfortunately, that's not cooperating with us today. The simplest bit of the system, the TV monitor, wasn't working. but you can see the quality of the picture on the small screen on the front panel. The 905 comes as 2 units. It has a masthead mounted brick, which has all the RF electronics in it, and a head unit, and the two connect together just by Cat5 cable. Basically just data and power goes up. Putting all the RF equipment at the top of the mast means you overcome all of the problems with feeder loss, and so everything is generated at the top of the mast, and you just basically operate it remotely from the bottom. And it can even be done through a wireless network. The unit itself has a GPS in it, so it uses the GPS signal to generate a frequency lock-in standard, so that all of the modes, whether it be digital or CWSSB, they're already phase locked to extremely high standard of frequency, both stability and accuracy. One of the problems that people have discovered with a 905 is that it has multiple RF outputs, one for each band. So this is one solution if for a very quick setup, portable or activity day, which is one dish and a multi-band feed. So there are cables coming up from the transverter head on each of the bands. So again, you haven't got multiple antennas or multiple dishes or grid packs, it can all go on one. One of the downsides of the 905 is that they did not include the 3.4 gig band on the basis that many countries have already lost access to 9 centimetres. We've got round it with this system because although it doesn't have 3.4 gigs in it, it does have 432, and we're using the 432 output to drive one of those SG Labs transverters that we talked about, and it takes the 10 meg reference out of the brick. So it basically adds in the one band that we're missing in Australia for just a few extra $100. And so as a mountain-top activity day option, this is very fast. It's a very high gain antenna on all the bands, and you can switch from the front panel between any of these bands at the touch of the screen, basically. And as you can see, it does both SSB, digital, and as we're showing here today, it does really good quality FNA TV pictures, which is another a whole new chapter, a whole new aspect of the hobby from the mountain top. So quite capable of TV pictures over hundreds of kilometres on any of the microwave bands that it can generate TV on. So there we have it. There's Cole's dish, Cole's feed, 1905 and another outside.
Kevin's 905.
And there we have it. That's another option, and you don't have to pick the soldering out. This is one solution if you have no interest or don't believe you have the skill set to build stuff yourself, which is probably not true, but you can actually just now go out and get what you want and be on the air if that's what really interests you.
Given the beauty of those is the cap length of the cable, because you put the whole unit at the head.
Yeah, you can have 60 feet of control cable, so you can be pretty high, and feeders are actually that long. That's all.
And as everyone keeps picking up, I'm like, oh, you can get a quality feeders.
Indeed. Okay, thank everybody who's brought equipment to display and talk about it. It's been an extremely successful day. I also want to thank again the Redcliffe Group for giving us the use of this facilities and supporting us with putting on the barbecue. That's going to be ready for us to have something to eat together shortly. And I thank all the members who actually wanted us to run this again. All of it's been filmed today. Hopefully we'll edit that up into something that's useful, put it up on the group's Facebook page library. And if anybody's got any questions about any of the gear, if you want to get into it and have a look at how all the working bits do, please do while you've got the chance. I'll certainly be having a look around everything as well. And thanks again for coming on a very hot and sticky day. At least it wasn't raining. Thanks for coming.
Thank you.
Okay, about 10 minutes till the snake.
Artie Graham has gone and stripped out all the gear that's normally sitting here. There's a couple of 9700s and a few other bits and pieces, but yeah, it's all very impressive in the little China caravan. He normally brings it himself. Beer fridge, very, very nice.
Cut that part off and exchange it.
The head is probably the last thing that will fail in my life. The rest of the body will just disintegrate.
Falling apart.
From the inside out.
How old are you now?
57 only.
Peace out.